So chapter 5 now.
Oh, we did.
What was the range for
For that one,
Yeah.
the range was
Isn't the range just like all around the circle?
that x has to be less than or equal to 6.125.
Okay, well.
Okay. That makes sense? Awesome. Okay, so radicals. So first thing we did is we did adding and subtracting radicals. So remember, when you're adding and subtracting radicals, the number under the radical sign has to be the same. So if I had something like 5 to the root 13 minus 2 root 13. Here, the radicands are the same, so you just add the numbers out front, or subtract the numbers. Oh yeah, subtract them. But I didn't subtract the same.
Okay, wait, so you can only do it at the.
Yeah. Let's do a bit of a harder one for you guys to see that. Like let's say it's something like this now. 2 root 18. Oh, sorry. 2 root 18 plus 9 root 7 minus root 63. Okay? So none of these are the same, right? So in theory, we don't do a thing. But these can all be simplified. Remember, you use numbers you know the square roots of. So I'll take my time and I'll show all my work here. So 18 is just 2 times 9. 7 is a prime number, so there's nothing to be done there. 63 is 9. 9 times 7. So remember now, when you simplify these, like for this one here, what's the square root of 9? Yeah, so just you bring the 3 out front, leave the 7 underneath. This one, nothing can be done. And then this one here, square root of 9 is 3 again. So when I bring the 3 out, right, so it becomes 6. Everyone's kind of remembering this now?
So it'd be 6 over, or 6 radical 2 plus 6 radical 7.
Yeah. 9 take away 3 is 6. What are you doing over there?
I have 3 couples and none of them work. Here then, found this one.
Wait, how did you get 6 too?
The 6? Square root of 9 is 3, right?
Oh, yeah.
So when I bring the 3 out, I have to multiply to the 2.
Yeah.
Right. Oh, yeah? That's not bad.
Whoa.
Whoa.
That's my
So I wanted to solve it, that's why I did that.
But you can't, they're all different answers.
At first they do, right? But you can
Oh,
simplify them.
But then you between them simplify them at the same, so you can just do the two that have the same rate.
Bingo! Look what happens when you pay attention and not play around with your pencils.
I was trying.
You're on the struggle bus.
And when I think, well, like my eraser won't come all the way back.
Mechanical pencils
Or,
are,
yeah.
The worst invention ever.
yeah. I got
See, look at Levi there, old school. Sharpens it in 30 seconds. He's good to go.
That was not 30 seconds, that was way faster.
Oh, probably.
You're not even supporting your own argument.
Wait, how'd you get 9.7? Oh.
9
It
point.
was at 9.7?
Yeah.
Yeah, so you could say 3 out of 9.
Yeah, because 63 is 9 times 7. Either way, yeah, 30 seconds total, and he sharpened it 2 times. That probably needs to be empty.
Absolutely given her with the,
What's that?
I just said absolutely given her with that.
Not bad. In the fall, I emptied it. I think that's the first time I've ever emptied it. Like, it was packed.
We've had that thing for like 2 or 3 years now.
I know, I just never think to empty it.
I remember, like, we were in here when you set that thing up. It was like the first day of school, like grade 9.
No, it was the last day. It was last day.
We didn't have last day grade 9. We were home.
You're right.
It was- you guys were in grade 9
We
for.
were trying to figure out how to put it.
Yeah, you guys were here for something, yeah.
Yeah.
Yeah, good times. We shared a moment together, that's nice. Okay, so that's adding and subtracting. Any questions about that? Excellent. Okay, multiplying and dividing works a little bit differently. Multiplying is really easy. Whatever it is, you just multiply it together. Let's say I had 703 times 505 minus 6 root 3. This is just straight up old distribution. Everything is multiplied by everything.
Then what's inside the radical multiplied by what's inside the radical, and what's outside multiplied by what's outside.
Right. So 7 times 5 is 35. 3 times 5 is 15. 7 times 6 is 42. 3 times 3 is 9. Now, if you can simplify the radicals, you do. 15, I can't simplify. 3 and 5, I don't know the square root of. Square root of 9, though,
Just take it.
right, take a 3. So this now becomes 3 times 42.
126.
Yeah. And that's done.
But you don't put it on.
No. It always is the second time you see something. Like quadratics this year was not nearly as bad as last. Right?
Did we struggle with that?
Yeah. Everyone does. Same with division. 6 divided by 3 is just 2. Now, division, it's never that easy.
After this, how many more new things do you learn, like foundation 30, got 30? Or is it all like building block stuff already?
No, you do graph transformations for most of it. Logs would be new. Graphing sine, cosine graphs would be new. But you learn that in Foundation 32. Then you do trig identities. And then there's probably some, I haven't taught pre-calc 30 probably 3 years now.
Is Mr. Hammer interested?
I'm assuming so. It'll be a broadcast class, so I won't.
You teach foundation 30?
I'll teach you guys that next semester.
Who does calculus there?
That'd be a DLC class. So I think Harem's doing it this year.
Oh, but it's pretty.
Yeah, it's broadcast. I haven't taught calculus since Carson and Neil were in school.
I don't know if I'd mind doing online.
But the teacher's there, right?
Well, no, like if I was in like another school,
Oh yeah.
I would, because like, my friend, what's her name, like,
Some friend you don't even know her name.
no, it's a managed startup. But anyway, it's because they're doing chem, and I think they're getting a broadcast.
Yeah.
And I would not want to do that.
Oh, it's with Mrs. Jameson, though.
I know, so,
Yeah.
science.
Okay, back to on topic. Let's say though I have something like this. 2 divided by, or 5 divided by 2 root 3. Now, unfortunately, with this stuff, there's nothing to be done, right? I can't simplify anything. So normally you would leave it. But the rule with radicals is you can't have a radical on the denominator.
Oh, you multiply it by the, well, what's the term? I don't know what the term is called. We multiply both the top and bottom by 2 radical 3.
Just radical 3. Just the radical.
Okay.
Okay? So multiply by the radical.
Sounds like funky math where this starts with S or something.
That's the next one.
Okay.
You multiply by the radical. This is called rationalizing. So you multiply top and bottom. Okay?
Wait, so,
Oh, yes.
a question, so why does that solve it from there, because you're not like divided in others?
Right. But anything divided by itself is what?
You're not.
No, I'm not, but just watch. Let me finish this and we'll go through it, okay? 5 times root 3 is just 5 root 3. Well, 2, the 2 stays there. Root 3 times root 3 is, but it's just 3, right? Square, and the square root of 9 Sierra is?
Okay, well, so 3 times 3?
Well, root 3 times root 3. Root 9.
Oh, and that's just 3, so it's 3 times 3, so that's just 6.
Right, it's just 6 on the bottom, because the square root of 9 is just 3. I'll show all my steps. You don't have to write this all out. You get it? Okay? So that's why you rationalize the bottom. All it does is it just gets rid of that radical sign. Right?
But what if you have it like out on the bottom, and then it doesn't get you a nice number that you can take the root?
It has to on the bottom.
If you're multiplying like a number by itself as well, like,
Yeah, you always multiply it by itself here, right? And then what that does is it just cancels out this radical and makes the actual number. Without the radical.
Like, so you don't have to do like this step of like 3 times 3 is 9.
No, you can just go straight to 2 times 3. Yeah, absolutely. Okay, now Sam is thinking about something weird that we're going to cover next. This time, get ready. Here we go. Let's say we have something like this. 5 root 3. So this is a new example. 4 minus root 6.
oh, it's like you multiply but you reverse the sign or something.
Right.
What's the word for that?
Conjugate.
Okay, what's that?
Conjugate. Okay. So you multiply top and bottom. So what's on the bottom here, but what you do is you multiply it by the opposite sign.
Is that right? So how do you know when you have these conjugates?
When there's a addition or subtraction on the bottom.
When it's not equal?
Yeah.
Why does that class move by so fast? Last period always takes forever. Come on. Every class is supposed to be at least an hour, right?
They're all like an hour and 3 minutes or something like that.
They're all the same length.
I believe so, yeah.
Afternoon feels like just as long as the morning does for us.
Period 3, hang on. Period 3 is a long period. Oh, sorry, so we should do the multiplication. So you're going to do like FOIL. Okay, FOIL. That's right. 20 root 3 plus 5 root 18 on the top. 4 times 5. What's that? Root 3.
Oh, so you take the whole first thing and multiply it first.
Yeah. Yeah, exactly. All right. And 4 times 4 is 16. 4 times root 6 is positive 4 root 6. Negative root 6 times 4 is negative 4 root 6. Root 6 times root 6. 16 plus 4 root 6.
Why is there 4 root 6 then?
Well, what's 4 times root 6? 4 root 6. You can't, things on the outside get multiplied to everything on the outside. You can't multiply a regular number to a radical, it just becomes 4 root 6. It doesn't become root 24. Like see here, like 5 root 3 times 4, 5 times 4 is 20, then the root 3 just stays there.
Yeah, I'm just confused on the whole, the whole part.
Well, just hold on, I'll show you what happens. Like it works out nicely. What's root 6 times root 6? 36, square root of 36 is just 6. Now, positive 4 root 6 and negative 4 root 6, what are they going to do? Right, they cancel out. So they're gone. Okay. So then all I'm left with here is 20. I'm just going to rewrite it so you guys can see what I have left.
16 minus 6.
Yeah. Does that make sense, you guys? Or 9 and 2. Right? 9 and 2 out of 8. Now, whenever you multiply something by the conjugate, look. 4 squared is 16. Root 6 squared is 6. And then you just subtract the numbers. You don't have to do all this silly FOIL here if you don't want to. It does this every time.
Not on the bottom.
Yeah, on the bottom it works out like this every time. You square both numbers and subtract them. Every time, because these two middle terms always cancel out. That's why we multiply by the conjugate. Yeah. Yeah. So now,
Oh, I see why I'm confused, because I didn't scroll, that's like, the one like the top one multiply. Actually, but then on the bottom, they're like two separate.
right
Like the 4 and the 6 and the 6.
here? No, yeah. You click your combine. Okay. So let's see here now. So if you want, you can take this a whole lot further. I can take a common factor of 5 out of everything. Right? 25 and 10 are all divisible by 5. And 18 is 2 times 9. Square root of 9 is 3, right? So
I didn't do any of the simplification. I just had my written down as 20 radical 3 plus 15 radical 2 plus 10.
you would get 4.5 out of 5. So then I take a 5 out of everything.
So when you take the 5 out, why do you have to
So 5 divided by 5 is 1. Square root of 9, though, is 3. Well, like I told Sam, if you wrote this, you get 4.5 out of 5. If you simplify it, you get 5 out of 5. Maybe 5.5. What's that? Oh, yeah, sorry. Whoa, good catch. Very well done, Levi. That's a 2.
That's not
Wait,
it.
why is this?
Well, 10
That
divided
looks
by
like
5.
the symbol for communism.
Hammer and sickle. Okay, so that's it. Okay, there's like 8 minutes. I'm not going to get into exponential equations today, or rational equations. So I'll have to do that on Monday. I might have to make some videos on the weekend for you guys to watch, because I don't know if we'll get through everything in 2 more classes.
Well, we only need to get through like chapter 6 and chapter 7, chapter 8. You know, we just did the chapter 1. So.
Yeah. So we might be able to, but I might make a video for chapter 8 stuff.
Sure you do.
And I could do 8, 9 as a video, just give that to you guys. Because I do have to actually help a lesson too. All right.